Hello students, welcome back to today's class on exponents and powers, and today we're going to have some practice session and let's understand how far we understood this topic. Right? My name is Avinash and I'm a graduate from IIT Kharagpur. Let's start today's session. So what's the first question that we are having today? Write the following in the standard form. As also we have discussed the same thing. How to write the numbers in the standard form, right? So standard form in the sense we need to use exponents. By taking the help of decimals, we have 0 point, okay, this is 0.0035, 0.0035. So now tell me how many points are there? 1, 1, 2, 3, 4. After the point, we have 4 decimal values, right? So this can be written as this point if you want to transfer the last, right? 1, 2, 3, 4. So that means you need to write 10 power minus 4. We need to shift that decimal by 4 places. You need to write that as 35 into 10 power minus 4. Why minus 4? Whenever you are going towards right, you need to write minus 4. Whenever you're coming towards left, you need to keep a plus. Okay. Or the same thing, when this point decimal is transfer only to the next 3 parts. 1, 2, 3. So here we can write as only 3. We can write 3.5. 3.5 into 10 power minus 3. Both are same. 35 into 10 power minus 4 or 3.5 into 10 power minus 3. Both are correct. Both are same. Right? What about 365.05? 365.05. We have 4 places. I mean, so we have 2 places. We need to shift that 0 to the next 2 places. So 36505 into 10 power minus 2. 36505 into 10 power minus 2. Okay, so that is how you can try to write that in the standard format. Next, write the following in the standard form. The same question again. Next question, which one is greater? So we have a question here, which one is greater? 2 cube, what do you mean by 2 cube? 2 into 2 into 2, which is 8. 3 square, 3 into 3 is 9. 1 power 8, 1 into 1 into 1, so on 8 times. 1 repeated any number of times will again give you 1. Will again give you 1. 4 square, 4 into 4 is 16. 4 into 4 is 16. Which one is greater? So we can say that 16 is greater, which is a 4 square. 4 square is greater among all these values, correct? Okay. What is the next one? The value of 2 power 9, it's very, very important. 2 power 9. That means we need to multiply 2 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So let me multiply each and everything, okay, one by one. 2 into 2 is 4. 4 into is 8. 8 2s are 16. 16 2s are 32. 32 2, 64. 64 into 2. 64 into 2, 4 2s are 8, 6 2s are 12, 128. 128 into 2. 128 into 2, 8 2s are 16, 2 2s are 4, 5, 2 1s 2. And 256 into 2, 256 into 2, 6 2s are 12, 5 2s are 10, 11, 2 2s are 4, 5. So it is a 512. It is a 512, 512. Okay, so the value of 2 power 9 is 512, 512. Okay, the value of 2 power 9 is 512. Clear? The next question, the exponent in the expression 3 power 7, x 3 power 7, the exponent is always this number 7. This is called base. So 7 is the exponent. So the option B, the straightforward question, very simple question. Okay, the next one, the value of 3 power 0. 3 power 0, I told you many times, any number power 0 will always give you 1. 3 power 0 is 1. 4 power 0 is 1. 5 power 0 is 1. Any number to the power 0, is 1. So option C is the correct answer. Option C is the correct answer. Okay, so the next one, multiplicative inverse of 1 by 7 is multiplicative inverse of 1 by 7. multiplicative, that means we need to find the reciprocal. We need to find the reciprocal. So 1 by 7 reciprocal, you'll get 7. 1 by 7 reciprocal, you'll get it as 7. Okay, so that option C is the correct answer. Moving forward, the value of 1 by 3 square is equal to 1 by 3 square, 1 by 3 into 3. It is 1 by 3 into 3 is 9. Very simple question. 1 by 9 is the correct answer. Okay. So the next one. In simplified form, 3 power 0 plus 4 power 0 plus 5 power 0 whole power 0 is equal to 3 power 0. Told you anything power 0 is always equal to 1. So 1 plus 1 plus 1. 1 plus 1 plus 1. How much is that? 3. So 3 power 0. 3 power 0 is 1. 3 power 0 is 1. In simplified form, 3 power 0 plus 4 power 0 plus 5 power 0 whole power 0. So again 1 power 0. 1 power 0. Okay, so 3 power 0. It's again equal to 1. So it is equal to 1. Right, it's not 3 because you have one more power 0. 3 power 0. Correct. So next one. The approximate distance of moon from the earth is 38446700 meters, and in exponential form this distance can be written as. So we have a couple of notations here. Once again, let's try to write the number. Okay, so what is that number? 38446700. 38446700, and in exponential form this distance can be written as. And in exponential form, this distance can be written as, carefully see here, if you want the decimal point here after 3, so we need to bring our decimal from here to 1, 2, 3, 4, 5, 6, 7, 8. So we can write 3.8446700 into 10 power 8. 3.84467 into 6700 10 power 8, but we don't have zeros here. We don't have zeros here. Carefully observe that. So what I can do here, okay, or else let's go for the second option. Here we have the decimal after 7. We don't have decimal. That means we have after 7. After 7, that means 38446700. So 1, 2, 3. So 3 places. 384467 into 10 cube should be there. Into 10 cube. I'm so sorry. Right. So here we are shifting that. Right. So 3 point. Here it is correct. How many places? 1, 2, 3, 4, 5, 6, 7, 8. So that is 10 power 8. This is 10 cube. Do we have that option? No. Right. What about the next one? What about the third option? 384467. Again the same thing. Right. What is the last one? The last one is again 3.84467 in 10 power minus 3. Okay, even that is not correct. Okay, so we don't have. Once again, let's try to understand what is the question. The approximate distance between the moon and the earth is 38446700 meters. Okay, so 3.84467 into 10 power 8. 10 power 8. So we don't have that option, but still you just need to have 3 zeros. You need to have 3 zeros to get the correct answer. Okay, I don't think it should be meters. I think it is the kilometers maybe. Right, whatever it is. Whatever it is, the correct answer for that number will be this. There is some printing mistake where some decimal point has been missing. Right, so this is how you can try to relate that. So moving ahead, 7 into 10 power 5 meters. 7 into 10 power 5. 10 power minus 5. 10 power minus 5 means you need to bring the decimal back by 5 places. Right, so 7 is here. Decimal is here. 1, 2, 3, 4, 5. 0, 0, 0, 0. So point decimal will be here. So 0.1234, 4 zeros and then 7. 0.1234, 4 zeros and 7. So option D is the correct answer. Option D is the correct answer. Okay. So moving ahead, the value of 6 power minus 1 minus 8 power minus 1 whole power minus 1 is. The value of 6 power minus 1 minus 8 power minus 1 whole power minus 1. 6 power minus 1, what do you mean by that? We discussed what is a power minus m, which is equal to 1 by a power m. which is equal to 1 by a power m, correct? So this is 1 by 6 minus 1 by 8. Let's try to first find this value and then let's try to go for the outer minus 1. So what is LCM of 6 and 8? It says 24 if I'm not wrong. Please try to find it out. LCM of 6 and 8 is 24. 6 4 is a 24, 4 into 1 is 4 minus 8 3 is a 24, 3 into 1 is 3. 4 minus 3 whole power minus 1. 4 minus 3 is 1, 1 by 24 whole power minus 1. Again, a power minus m is 1 by a power m. So 1 by 24 1 by 24 can be written as 24 power minus 1 whole power minus 1. 1 by 24 can be written as 24 whole power minus 1. So which is now equal to 24 power minus 1 into minus 1 will give you plus 1. Minus 1 into minus 1 will give you plus 1. So 24 power 1, which is again simply equal to 24. 24 power 1, which is equal to 24. So option D is the correct answer. Option D is the correct answer. Okay. So moving ahead, the next one. If 5 power 2x plus 1 divided by 25 is equal to 125, then the value of x is. The point is, we need to convert this in terms of 5 powers, in terms of exponents of 5. This is already with 5, so don't worry about that. 5 power 2x plus 1. And the down 25 is 5 square. And this 125 is 5 cube. 125 is 5 cube. 5 into 5 into 5. 5 5 is 25 into 5. 5 5 is 25. 5 2 is 10, 11, 12. So 25 into 5 is 125. A power m by a power n. A power m by a power n. The formula is a power m minus n. The formula is a power m minus n, right? So that will give you 5 power 2x plus 1 minus 2 is equal to 5 cube. So now, as the bases are equal, we can try to equate the exponents. So 2x plus 1 minus 2, 2x, 1 minus 2 is minus 1, 2x minus 1 is equal to 3. 2x minus 1 is equal to 3. That will give you 2x equal to 3, minus 1 will come here, plus 1. So 2x is equal to 3 plus 1 is 4. X is equal to 4 by 2, which is equal to 2. X is equal to 4 by 2, which is equal to 2, right? So that is again option A. That is again option A. Alright, 5 power 2x plus 1 by 25 is equal to 125, and the value of x is 2. So let's move forward to the next question. If 2 power 3x minus 1 plus 10 divided by 7 is equal to 6, then the value of x is, okay, let's try to see that. 2 power 3x minus 1 plus 10 divided by 7 is equal to 6. So can we convert this 7, can we move this 7 to the other side? What will happen? 7 into 6 is 42, right? So 2 power 3x minus 1 plus 10. 2 power 3x minus 1 plus 10 is equal to 7 6 are 42. 7 6 are 42. Right? So 2 power 3x minus 1, 2 power 3x minus 1 is equal to 42 plus 10 is here, will become minus 10. So 2 power 3x minus 1, 2 power 3x minus 1, 42 minus 2, 42 minus 10 is 32. 42 minus 10 is 32, okay. So now 32 we can write as 2 power 5. 2 power 3x minus 1 is equal to 32. It is a 2 power 5. It is 2 power 5. So can we see these two? Can we equate these two? So 3x minus 1 is equal to 5. 3x equal to 5 plus 1 is 6. So x is equal to 6 by 3. So x will take the value of 2. X is equal to 2. So please copy this question carefully. We'll go for this next question. All these questions are very simple. The only process is we need to equate the bases. We need to make the bases equal. So when the bases are same, when the bases are equal, we can directly equate the exponents. Okay. So please try to copy this properly so that we can go for the next question. Similar type of thing, we'll try to discuss one or few more questions. Right. So the next question we are having. What is the next question we are having? Find the value of x if minus 3 power 3x plus 1 into minus 3 power 4 is equal to minus 3 power 8. Minus 3 power 3x plus 1 into minus 3 power minus 3 power 4. A power m into a power n. A power m into a power n, which is equal to a power m plus n, which is a power m plus n. So this is minus 3 power m plus 1. 3x plus 1 plus 4 is equal to minus 3 power 8. So that will give you minus 3 power 3x plus 5. 3x plus 5 is equal to minus 3 power 8. Minus 3 power 8. Okay. So now we can equate these two. So you can write 3x plus 5 is equal to 8. So 3x is equal to 8 minus 5. So 3x is equal to 3. So 3x is equal to 3. Divide with 3. So x is equal to 3 by 3, which is equal to 1. So what is the final solution? X will be equal to 1. If you want to verify it, just substitute back. If you substitute 1 here, 3 into 1 is 3, 3 plus 1 is 4. So 4 plus 4 will give you 8. That's an exactly correct answer. Okay, so I hope all these questions are clear to you. So let's try to discuss one more. 81 power minus 4 divided by 729 power 2 minus x is equal to 9 power 4x. 81, 729, 9. So some relations between 9 maybe. 9 or 3. 81, I know it is 9 square. 9 square power minus 4. Divided by, what about 729? 729, if I'm not wrong, 81 into 9. 81 into 9. So 9 ones are 9, 8 is 16, 72. 729, so 81 is already 9 square. This is 9. So this is a 9 cube. 9 cube, you can find 9 into 9 into 9, you will get 729. 9 cube power 2 minus 6 is equal to 9 power 4x. So we can write this as 9 power 2 into minus 4 is minus 8 by 9 power 3 into 2 minus 6 is equal to 9 power 4x. A power m by a power n is equal to a power m minus n. So 9 power minus 8 minus 3 times of 2 minus x is equal to 9 power 4x. 9 power minus 8 minus 3 times of 2 minus x is equal to 9 power 4x. Okay. So now we need to equate these two. As the base are equal, we can directly equate these two. But when you are multiplying with negative, be very sure how to multiply properly. Minus 8 minus 3 into 2 is minus 6. Minus 3 into minus x is a plus 3x is equal to 4x. Minus 8 minus 6 plus 3x is 4x. Okay. So minus 8 minus 6 is minus 14 plus 3x is equal to 4x. So take this 3x here. Minus 14 is equal to 4x minus 3x. Minus 14 is equal to x. So we'll get x is equal to minus 14. So what is the value of x that satisfies this equation? That is a minus 14. There may be some calculation mistakes that might have appeared sometimes. So please try to get rectified. Please try to see if there is any mistake and please try to rectify them. Right. So I think all these questions are very clear to you. In the next class, we're going to discuss the next topic. And there are a lot many applications based on exponents and powers which are very, very, very important. This concept is a very useful and very important concept. Right? Not only for the state boards, not only for the foundations, for any competitive examinations, right? Exponents and powers questions are very interesting and very simple to solve if you're clear with all the laws of exponents. Right? Thank you so much, students. Stay tuned to get the next lecture. Thank you.
Hello everyone. So now we'll be discussing about charge. Okay, my name is Sashan Reddy. I'm a graduate from IIT Dhanbad. Let's go into the class. Okay, chalo. So first of all, to understand charging, let's go into a simple question or simple situation that we all know about. What is that? What happens when two objects are rubbed against each other? Or a better example, we can take this situation, similar situation. You take a comb, rub it on your hair and place it on paper bits. What happens to the paper bits? The paper bits fly up and get attracted. The same thing happens with this also. When two objects are rubbed against each other, they get attracted. Right? Good. Now another question will be, which force is responsible for that? When the forces that we know about, let's count the forces that we know about. Gravitational force, magnetic force, friction, spring force. Which force? Not all of them. There is a new force called as what? Electrostatic force. Yes, you are correct. Which force is that? Electrostatic force. It is also what? A non-contact force. Electrostatic force, and it is what? A non-contact force. Contact is not required. Contact is not required. That is electrostatic force. Now, electrostatic force is similar to magnetic force. Remember that in mind. Electrostatic force is similar to magnetic force. If you compare with them, it will be easier to understand. But electrostatic and magnetic are completely different. So, in the case of magnetic force, force will act between two magnets because of what? Because of magnetic poles. North pole and south pole. Like poles repel each other, unlike poles attract each other in the case of what? In the case of a magnet. Now let's see what happens in the case of an electrostatic force. Let's try to understand them through a few examples first. So let's take a simple case. Read them carefully, understand them carefully. Okay. So there will be three different cases that we will be discussing about. First one. Hang an air-filled balloon using a string or a rope. You can see the balloon which is hung using a string, a rope. Right. Then bring a plastic pipe. You can see the pipe, yes or no, in this image as well as in that image. You can see the pipe. Bring a plastic pipe near the balloon and notice if anything happens. So if you have a balloon here, and if this is the rod, plastic rod, normally nothing happens. So here in the first case, nothing happens. Then what we will do is, we'll rub the same plastic pipe with a woolen cloth. See here, it's like a monkey cap. Right, it's a monkey cap. So you are rubbing the plastic pipe with a woolen cloth, and then after that bring the pipe near the same balloon again. And notice what happens. What happens is the balloon will be attracted to the pipe as shown. The balloon will be attracted to the pipe. So what was the difference between first case and second case? When the plastic pipe was brought near the balloon at the beginning, there was nothing would have happened. Why? Because there is no rubbing in that case. But in the second case, you rub the pipe and then bring it near the balloon. Then what happens? The balloon gets attracted to it. So rubbing is doing something there. Rubbing the plastic pipe with the woolen cloth is doing something. Okay? Okay. One example, first case. You can say it is what? Case 1. Okay? Then I'll go into case 2. Another example. We'll take two balloons now. So same, hang the two balloons using threads. Do it. Suspend two air-filled balloons using a string or a rope and let them come to rest. Do not switch on fan. No. Switch off fan, close the windows. No wind should flow. When you close the room, do this. Suspend or hang two balloons, air-filled balloons. Then rub both the balloons with a woolen cloth. So take the balloon, the first balloon, rub it with what? Rub it with a monkey cap, woolen cloth. Second balloon also rub it with a woolen cloth and see what happens. What happens is they will repel each other. They will go far away, something like this. They are going far away. This is the image of what? They repel each other. So this is case 2. In case 2, what did we do? Again, let us summarize. Whatever we have done for the first balloon, we have done the same for second balloon. See, rub both the balloons with a woolen cloth. So these two are similar now, right? Similar cases. So whatever would have happened for balloon 1, the same thing will happen for balloon 2. Because you are rubbing the balloon 1 with a woolen cloth, balloon 2 also with the same cloth. So whatever happens for 1 should have happened to 2. So they are same. And between them there is repulsion. Between them there is repulsion. Case 2. We'll try to understand them, don't worry. These are examples of what exactly happens. Practical examples. We'll go into case 3 then. Now what is the case 3? Same again fresh. Suspend 2 air-filled balloons using a string or a rope and let them come to rest. Okay, then. Rub one balloon, then let's say this is one balloon, we'll rub it with a woolen cloth and the another balloon with what? With a polyester cloth. So that's another one. So now whatever happens for balloon 1 need not happen for balloon 2. Because for 1 we are rubbing it with woolen cloth, for 2 we are rubbing it with another type of cloth, polyester cloth. That means both need not be similar in that case. And see what happens. They attract each other. They attract each other. Let's say this is case 3. So some practical experiments. Even you can try doing this at home. Very simple, basic experiments. You don't need anything much. Whatever you need, they will be available in your homes. So please try doing this. Okay, now case 2 and case 3 are more important for us. In the case of case 2, there was repulsion between similar balloons. But in the case of case 3, there is attraction between different cases of balloons. So okay, is it similar like magnet? North, same poles, repel. In the case of magnet. South, same, repel. But north-south or south-north, attract. It's like that balloon, right? See, 2 different balloons. One was rubbed with a woolen cloth and the other was rubbed with what? A polyester cloth. So it's like 2 different balloons you can think. They were attracting. Like unlike poles attract. And whereas similar balloons, when both the balloons were rubbed with woolen cloth, they were repelling. Right, so some analogy, some comparison. Right, so what can we summarize or observations? The first one is, between charged bodies of the same type, 2 balloons rubbed with the same woolen cloth repel each other. That's why I told charged bodies of the same type. Same type, right? Yes or no? They are rubbed with the same woolen cloth, so they will be of the same type and they repel each other. So here repulsion took place. Whereas if I take the other case, the case 3, between charged bodies of different types, one balloon rubbed with woolen cloth and the other with polyester cloth, what happened? Attraction happened. So that specifically proves that there are 2 different type of charged objects. That much we should be able to tell. 2 different type of charged bodies. Okay, so this proves that. Okay, that's good. And rubbing leads to charging and charging leads to electrostatic force. Electrostatic force can be repulsive or can be attractive. Electrostatic force can be repulsive or can be attractive. Okay, that much is clear for all of us. Chalo. So here, now that we understood there are 2 different type of charged bodies, right? We call them as charges. We call them as charges, like poles, like magnetic poles, we call them as charges. Okay, what is the name? Charges. And those charges are responsible for what? They are responsible for electrostatic force of attraction or repulsion between objects. So that is the definition. Charge, what is the definition? It is the property of matter which is responsible for electrostatic force of repulsion or attraction between objects. Okay, and the charged bodies acquire charges. They get charges. They get charges when they are rubbed against each other, and we name them. There are two different types. We name them as, one we call it as positive, the other we call it as negative. There is no reason behind it. They are just names. One we call it as positive charge, the other we call it as negative charge. Positive, negative. These are charges. Okay, so charge is nothing but a property. Like magnetic pole. Pole is a property of magnets. Mass is a property of objects. Like that, charge is also a property. Okay, good. And how many different types of charges are there? This is very important. Positive and negative charges. Positive and negative charges. And this comparison, this similarity between electrostatic force or charges and poles. Look at the similarity between them. Charges, positive charge, right? There are how many charges? Positive charge, negative charge. How many poles? North pole, south pole. Then positive charge, repulsion. North pole, repulsion. Similar. Negative charge, repulsion. South pole, repulsion. Positive charge, negative charge, attraction. North pole, south pole, attraction. Obviously, if I take negative and positive, then also there will be attraction. If I take south and north, then also there will be attraction. They are not the same, but they are similar. Here also you can say like charges repel. Like charges repel. What about unlike charges? Unlike charges attract. Unlike charges attract. Same as like poles repel, unlike poles attract. Similar to that. Similar to that. Clear? Good. We'll try to understand them in much more detail. The same point that we discussed is here. Okay. Let's summarize whatever we have learned. When it comes to electrostatic force, what is responsible for electrostatic force? Charge is responsible. How many charges are there? Two types of charges. One is positive charge, the other is negative charge. Between the like charges, positive, repulsion, negative, repulsion. Between unlike charges, positive, negative or negative, positive, attraction. Simple basic points. These are the important points that we have learned until now. One more hidden point that we have learned is when we rub objects, they get charged. How? We will learn about it later on. Okay, chalo. Now the question is, there is an interesting question that this boy asks. Where do the charges come from? Where are they? We know magnetic poles are at the ends of a magnet. Okay, but where are the charges? Where do they come from? Right? And to understand that, we have to understand what is inside an atom. I hope all of you know what is an atom, right? Any substance, let's say that if I take this pen, now if I break down this pen, if I keep on breaking down the pen into parts, very small parts, or if I see this pen under a microscope, it's like zoom into it, then I'll find an atom, right? The smallest indivisible part of any substance. So inside an atom, there are two main things, two main parts, two main particles, let's say, two main particles. One, the red one, which is not moving, which is exactly at the center, that is called as nucleus. And the particles that are moving, revolving around the nucleus, are called electrons. Now that is similar to planets revolving around the sun. So if you want to imagine, you can imagine there is sun, planets are revolving around the sun. Similarly, there is nucleus, electrons are revolving around the nucleus. The only difference is they are very, 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 very small. We can't even see it. We can't even see them. Very, 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 very small. Okay? Good. So what does an atom contain? An atom contains a nucleus and particles called electrons revolving around the nucleus. So this here is the nucleus. That red one is the nucleus, and the other particles that are revolving around the nucleus are electrons. Good? Nucleus and electrons. First point. Now the charges come from them. Again, the same point is similar to planets revolving around the sun. We just understood. The charges come from them, that is, they come from very deep inside. These very small particles, those have charges, and that's how the complete body will be charged. So electrons are negatively charged. The property of electrons are what? They are very small particles. They are well defined and they are negatively charged. Whereas nucleus is positively charged. Electron is negatively charged and nucleus is what? Positive. You have to remember those points. Electrons are negatively charged and nucleus is positive. Okay. So it's similar to this. The center you have positive charge and the electrons will be revolving around what? Will be revolving around the nucleus. Obviously here there can be, what do you call, multiple electrons also in one orbit. That all you will learn later on. I'm just giving you a picture. Nucleus is positive and electrons are negative and they are revolving around the nucleus. Okay. It is similar to what? It is similar to the sun at the center. The sun at the center and planets revolving around the sun, like Earth revolves around the sun, Mars revolves around the sun, Mercury revolves around the sun. So those are the interesting properties. Similar. Good. The only thing is atom will be very, very, very small that we cannot even see it directly. Even if an atom is present right in front of you, you cannot see it. Okay, that's how small they are. And now let's go into nucleus. We learned about electrons. Okay. If you break electrons, you cannot break them, by the way. You will get nothing. Nothing. But if you break atom, if you break the nucleus, okay, if you look into the nucleus carefully, then you will find something. And what do you find in the nucleus? You find two types of particles, proton and neutron. You will find two types of particles, proton and neutron. These are some things that we have to remember. These are experimentally proved, right? So we have to remember them as of now. So nucleus further contains protons and neutrons. Protons are positively charged and neutrons are neutral. What does that mean, neutral? Not positive, not negative. Zero. They have no charge. Neutral will mean they do not possess any charge whatsoever. Okay. So here you can say neutrons are neutral, they have no charge. Protons are positive. That means if you take both of them together, nucleus will be positive because it is plus. That is 0, plus 0. Like let's say plus 1, plus 0. It will be plus 1, right? So if you add positive and 0, you get positive. That means the nucleus will be positive because of protons. The positive charge of the nucleus comes from the protons. Okay. So coming back, there are three elementary particles: protons, neutrons, electrons. Protons are what? Positive. Electrons are what? Negative. Neutrons are what? Neutral. See the name itself, neutron, neutral, no charge. Okay, no charge, or you can say zero charge. These are the elementary particles present inside an atom, and any object, if it is charged, it will be because of this. So rubbing, yes, but during rubbing something happens, but ultimately these particles are responsible for charge. We'll learn that later on when we go into the topic charging. For now, our focus is to understand this. Understand the charge. Okay? Good. So protons positive, electrons negative. Good. Wonderful. Now, let's go into a simple question. Do two electrons repel or attract each other? I'll just change the question. Do two electrons repel each other? Yes or no? What do you think? Do two electrons repel each other? Yes or no? Everyone? Yeah? Do two electrons repel each other? Yes or no? What do you think is the answer? Whatever we have learned until now, think in terms of that. Think in terms of that. Yeah? And the answer is yes. They repel each other. Why? I'll explain. So if I say this is an electron, this is an electron. What are their charges? Electron is negative, electron is negative. Both of them are negative. And what happens between like charges? Repulsion takes place. Negative, negative, repulsion. Positive, positive, repulsion. Negative, positive, attraction. But for now, we have like charges, negative, negative. They repel each other. They do what? They repel each other. Understood? Okay. Chalo. Let's continue. Then again, this kid always asks interesting questions, right? So what is this kid asking? This kid is asking, what exactly happens when objects are rubbed against each other? How do they become charged? Right, let's try to understand that also. What happens is electrons jump from one atom to another atom, from one object to another object. Right, let's look at them. So when two objects are rubbed against each other like that, like they're rubbing, what happens is electrons move from one object to another. Not nucleus, not protons. What moves? Electrons. Electrons, not anything else. The object that gains electrons becomes negative. The object that loses electrons becomes positive. How? What does that mean? We'll understand that through a few examples, but these two are important points. Very important. Let's look at how. Let's see what happens when an object loses electrons. Let's say this is an atom. Okay, understand that this is completely an atom. And what does an atom contain here? The atom contains 5 electron, 5 proton and 5 neutron. Before this, there is one point you have to understand, that is charge of 1 electron is equal to charge of 1 proton. Charge of 1 electron is equal to charge of 1 proton. How much is that? That is not required for us. Okay, we'll just call it as E. E is the charge. That means, here if I look at this, there are 5, how much? 5 electrons. There are 5 electrons, 5 protons. Matlab 5 negative, 5 positive. So if you add both, what happens? Minus 5 plus 5. Minus 5 plus 5, what is that? 0. And what about neutrons? You have 5 neutrons, but they are already 0. They have no charge. So that means I can clearly say that this is neutral. They have no charge at the beginning. They have no charge at the beginning. But if it loses 1 electron, see what happens. It loses 1 electron, it has 5 at the beginning. If it will lose 1, it will have 4 electrons. So it has how many? 4 electrons. Now look at this. Negative minus 4. Positive plus 5. Neutron doesn't matter, 0. So you count them, minus 4 plus 5, simple integer addition, minus 4 plus 5. How much will you get? You will get plus 1. That means it is positively charged. It is positively charged. So if an atom loses one electron, a neutral atom, let's say if a neutral atom loses one electron, it is becoming positive. See, electron is like negativity. If you lose your negativity, you become positive. General situation, right? If you lose your negativity, if you let go of your negativity, you become positive. The same thing happens here also. Philosophy, right? If the neutral atom loses one electron, it is losing negative charge, losing negativity, it becomes positive. Okay? But if I take the other case, again see 5 electron, 5 proton, it means neutral atom, 5 negative, 5 positive, total 0. Neutron doesn't matter, it already has 0 charge. If it gains one electron, electron is negative, so 5 electrons become 6 electrons. 6 electrons, 5 neutrons. Now you tell me how is it charged? Is it negative? Is it positive? Or is it neutral? You tell me. After gaining one electron, how is it charged? Yeah? Here it is 6 negative, 5 positive, neutron is 0. If you add them, minus 6 plus 5, it will be minus 1. That means it is negatively charged. So the object that gains electron is negative. If you gain negativity, your mind becomes negative. If you listen to negative thoughts, if you entertain negative thoughts, your mind becomes negative. Right? Same logic. Right? So what happens is, when two objects are rubbed against each other, electrons will go from one object to another. When two objects are rubbed against each other, electrons will go from one object to another. So here, this object becomes positive as it loses electrons. Whereas this object gains electrons, so if it is gaining negativity, it becomes what? It becomes negative. Understood? Yes, so please practice this, everyone. Okay, when you practice, you'll understand it better. It's simple math. Got it? So coming back to the topic, the points that we discussed here, the important points. So what happens when two objects are rubbed against each other? Electrons move from one object to another. So one object will give electrons to other. One object is losing, the other object is gaining. The one that loses, the object that loses electrons, it is losing negativity, it becomes positive. The one that gains becomes negative. Okay? So these points are important. I hope you understood them. Wonderful. Chalo. Just a minute. Let's go into a simple question here. A very simple question. There are 7 electrons, 6 protons and 6 neutrons in an atom. 7 electrons, 6 protons, 6 neutrons in an atom. What is the charge of the atom? You tell me. There are 7 electrons, 6 protons, 6 neutrons in an atom. What is the charge of the atom? Positive, negative, or it is neutral? A, B, C. What is the answer? Yeah, everyone. It will be negative. Why? See here. There are, according to the question, there are 7 electrons, right? 6 protons, 6 neutrons. What is more? Negative is more, right? Here you can clearly see minus 7. 7 electrons. So negative charges how many? 7. So minus 7. Protons are just 6 plus 6. Neutrons are 0. You add them. Minus 7 plus 6. Minus 1. If you have more negative thoughts in your mind, obviously you will be negative. Here there are more negative electrons, so the atom will be negative. The atom will be negative. Understood? Okay, so now we learned about what in today's class we learned about charges. Different type of charges, positive, negative, how they attract and repel each other, and where do charges exactly come from. Okay, the rest we'll learn in next class. Until then, take care. Thank you.